Okay, Assalamualaikum and a very good day to my beloved panel. And my name is Muhammad Amir Shabirazan, and I will present about my project, which is Detachable Smart Helmet System. So my matrix number is DE180125, and also my supervisor is TS Azizul Muhammad. Okay, so and we proceed to my presentation. Okay, so the problem statement of this project is mainly for the crashes or accident that happen to a motorcyclist, which is have a very high fatality on the road, which is they compared to the other vehicle, which is like car. The safety features of a motorcyclist is reduced, which is have a low safety features compared to the car, and also the chances of nearby people knowing that there were accidents happen to the motorcyclists were very low, is actually. And also there were few articles that prove that this statement, which is some cases reported that their body were found after a week the accident happened. And also the vulnerability of this accident that may happen to the motorcyclist, which is very high, is more likely to happen by Foodpanda, GrabFood, and also post laju riders. And the solution for this problem is to create a road assist system that are compact to and easy to use by the user, and also detachable, which is and also equipped by uh, an accident detection an accident detection for the user. Okay, so for the objective is to develop an alert system for nearby authorities in event of accident, to create a system that enables emergency alert and detection for incoming vehicle to prevent the backward collision of the user, and to develop a front view system for erration detection, which is more like a dash cam function, and to design a device that can fit most of the helmet type and easily detachable. Okay, so for the scope of study, we use ESP8266 as our main control unit. The accelerometer as crash detection sensor is by adjusting XYZ value to certain threshold to trigger the specific function, which is the detection. And also the system is viable only during clear fine weather, which is in cloudy weather. The system is not very accurate in terms of the GPS location. Okay, so next is alerting and positioning features using GSM network, and operates at a range of maximum uh, of 35 km distance. And also the types of helmet used and compatible with this system is a standard motorcyclist helmet, which is that doesn't have any extra accessories at the top of the helmet itself. Okay, so for the methodology, we have three function in this device features, which is the alert, accident alert, the backward collision alert, and also the front view system. Okay, so for the first one is the accelerometer input reading will detect whether it is crash or not, and if the crash happen, it will locate the location of the user using the GPS, and also will trigger the SMS alert via GSM in the form of SMS. Okay, so the next is ultrasonic sensor input will detect whether the vehicle is near or not. So if the vehicle is near, the buzzer will alert the user in approximately 1 to 145 distance from the user. And the last one is the input image by camera module, which is we can use it as live streaming, and also whenever the camera is on, we can view the video via IP address. Okay, so for the result and analysis, okay, for the first features is the accident detection system, which is we use the accelerometer as our main sensor unit, which is whenever the orientation met a certain threshold, the accelerometer itself will send data to the microcontroller and detect it as a crash. Okay, so after the threshold has been limit or reached, the GPS location will be fetched and also stored via microcontroller, and then after that the GSM module itself uh, will send SMS to the user in the form of message that have a crash location and also the location and coordinate of the user. Okay, so if we can see here, this figure is the GSM module send the crash location via to the set number, which is it can be anything, it can be anyone, which is we mainly uh, take the priority to the authorities to alert them. And then in the next figure is this the Google Maps, which is after the GPS module fetch the location, it will display via Google Maps instead of raw GPS location to enable easier detection, which is we can locate the user. Okay, so for the backward collision alert system, after the device is being turned on, the backward collision system acts as a standalone system which doesn't require any data from the other component. Okay, this here, okay, so if we compare to the first system is the accident alert, which is we use the GPS system, which is the GPS at first need to communicate to the satellite to create a time to first fix. This time to first fix is what I can explain is that uh, it transmits signal to the satellite, and then during downlink process, the satellite will locate this GPS signal and also locate the user. Okay, for that particular system, they need some time to authenticate the connection between the satellite and also the module itself. So in this backward collision system, they doesn't require any of that, so it can be considered as a standalone system, which is after we turn on the device, the system itself will turn on. And also as the object comes near user, let's say an incoming vehicle, the ultrasonic sensor will detect the object or any incoming vehicle through sound wave propagation, which is processed via the microcontroller itself. And then after the object comes near user within 1 meter, the microcontroller will send data to the microcontroller to trigger the buzzer to notify or alert the user itself for any incoming vehicle or any obstacle that were behind the user. Okay, so for the last system is the front view camera system, which is whenever the device been turned on, the camera will generate IP address, which able user to connect the camera via the IP address. So this IP address can be used at any device or platform, which is more like a website. Yes, we can view via our laptop, our PC, or our phone. Okay, so in this figure, I use it for phone purpose. This is a view from the phone. Okay, so the camera also will act like a dash cam if we put the SD card onto the camera, and it will record all of the the evidence, record the evidence of any accident event. So there were two mode in this ASP cam that I use, which is for the live streaming and also for the recording. Okay, so for the performance, okay, so right here is the basically the design of experiment, the DOE that I use or to determine the performance of this system. Okay, so this design of experiment, the first one is the clock average versus GPS time to first fix, which is the manipulated variable here is the clock coverage, and also the responding variable is time to first fix. Okay, so as I said before, the time to first fix needs some time. Okay, it depends on the clock coverage actually. So in this very particular DOE, uh, uh, the clock coverage is being captured uh, for 20% to 100%, which is 20% is at clear and 100% is at cloudy, which is going to rain. So the time to first fix, if you can see in this table, which is as the clock coverage increase, the time to first fix is also increase, which is the GPS takes some time to connect to the satellite. If the cloud is too thick, the connection to the satellite may take some longer time compared to when it is clear, which is the fastest one is 6.37. So it is said, can be said that as the clock coverage is increased, the time to first fix is also increased. Okay, so and for this design of experiment, we want to study the relationship between the temperature of the surrounding and also the accelerometer reading. Okay, so for it is said that the accelerometer provides user with the direction of gravity. So the link between gravity and temperature is related, which is here we trying to um, to what is it to experiment whether the temperature affect the accelerometer reading, because the accelerometer use gravity to uh, to detect the raw value of the sensor. Okay, so here the manipulated variable is the temperature, and also the responding variable is the error of sensor orientation reading. So we take the room temperature reading at 27 Celsius as our reference, and so if uh, we high the temperature, which is as the temperature high, the orientation reading compared to the reference reading here and also here, it is said that the orientation reading is decreasing as the temperature is high. Okay, so if we lower the temperature 25, 23 and also 18, if we compare to the reference reading, the reading here is higher than the reference. Okay, so it is said that it can be concluded that the higher the temperature of the object, the gravity, the absolute value of the gravity will be small, and also the accelerometer reading will be lower. Okay. Okay, so now is for the vehicle speed versus ultrasonic accuracy. Okay, so in this DOE, the results from the sensor value show a slight variance of roughly 0.01 meter to 0.03 meter indicating from a specific distance if the object travel at a particular speed. Okay, so in this DOE, we are trying to experiment whether the speed of the moving object really affects the ultrasonic accuracy when detecting object or vehicle for 1.5 meter detection. Okay, so if you can see in this table, as the approaching speed is increased, so the actual reading from sensor for 1.5 meter detection is decreased. Okay, the decrease is between 0.01 to 0.03, and the error for 1.5 meter detection also increase. Okay, so here in this DOE, the actual reading from the sensor obtained for 1.5 meter detection can be considered uh, decreasing because of the time lag for the microcontroller to process data, because according to the theory, ultrasonic sensor uses sound wave to propagate and detect distance between object. So the speed of the for the sound wave is actually 340 meter per second. So theoretically it will not affected by the moving object, as the moving object's approaching speed is only at 1 kilometer per hour uh, to 20 kilometer per hour, so which is it shouldn't be affected. But here we obtain the reading from the sensor of 1.5 meter detection is decreasing, maybe because a big the main the main reason for this issue is most likely because of the microcontroller itself. Okay, so this is the graph of the DOE acquired or generated from the table. Okay, so for the last DOE is the surrounding temperature versus the ultrasonic accuracy. So in this device we use a lot of DOE to determine whether the ultrasonic accuracy is accurate or not. So in this DOE we try to what we call it, to experiment whether the temperature affect the ultrasonic accuracy. And here is the temperature, and the responding variable is the error here. So we take room temperature of 27 Celsius as our reference, and if we increase the temperature reading, the actually the sensor the ultrasonic sensor uses sound wave to do most of the job of the ultrasonic sensor, which is detecting the distance. So if the temperature increase, the sound wave will tend to move faster from the main point, the original point, compared to when the temperature is low, which is the sound wave will travel at lower speed than the high temperature. So if you can see here, the reading of the distance in this if the temperature is low, which is here we got of 1.52, so the distance will seems much further because the ultrasonic move much slower, the sound wave, what I mean. Okay, so for the if the temperature is high, the error here is 1.5 below 1.5, which is indicate that the sound wave travel faster to detect the distance. So the propagation of sound emitted by the ultrasonic sensor travels quicker at high temperature, which one of the key causes for the readings behavior. And sound waves travel quicker to and from the target as the temperature rise. Okay, so this is the product dimension. Okay, the product dimension is 98mm times 67mm times 49mm, which is while the dimension of the battery case is at 66mm times 20mm times 30mm. Okay, so this project is weighs less than 500 gram, which is 350 gram, which is it doesn't affect much of the helmet's original weight, and does not cause any strain when users wearing the helmet. Okay, so this is from the front view, the rear, the side view, and also from the back view. This is the ultrasonic. Okay, so this is the finished product implemented and attached to the helmet. So which is here, this is the front view, the side view, and also the back view. Okay, so conclusion and recommendation, which is based on the design of the experiment. This device have various offset output that varies respectively with different temperature setting, and it is because the raw data obtained by component and sensor are responding to the temperature changes. So in terms of functionality, this device are able to carry out the required tasks and also cater all the objectives stated as such as the accident detection, vehicle collision, and also the additional camera view. Okay, for the recommendation, which is we have two here now, which is the first one, we have to use a better GPS module, which is the Neo Max 8 series, which is have a better and faster time to first fix, so that user won't be able to wait for a long time for the GPS to initiate connection with the satellite itself. So for the ultrasonic sensor, we use the sorry okay we use the max Baltic high resolution ultrasonic rangefinder, which is the sensor have a quicker detection than this current ultrasonic sensor, because it have extra 2 kilohertz of frequency, operating frequency, which is can detect the distance much quicker and also more accurate. Okay, so that's all from me. Thank you.